Okay, good morning, everyone. Welcome to Information Technology Sessions number 1 of 2022, the International Conference on Electrical Engineering, Electronic Computer, Telecommunication, and Information Technology. My name is ROOM3 and I'm a session chair of this section. Okay, before the presentation start, I would like to inform you that the session is online presentation. So the session host will play your record video for presentations for 12 minutes top, and there will be 3 minutes for question and answer time slot for each paper. The presenter can interact with all audience at any other time through either the session chat room or a private message. Yes. Okay. We will start with the first paper. The title is Comparative Study Misclassification Cost Assignment Strategy for Cost-Sensitive AWS in Imbalanced Data Classification. Session host, please start the video recording.
Hello, I will talk about my research. The topic is a comparative study of misclassification cost assignment strategy for cost-sensitive database in imbalanced data classification. Introduce. Supervised learning machines have been employed to learn the relationship between data samples and their class assignment, so that the model can use to classify an unseen sample drawn from the same distribution with high accuracy. There are an increased number of classification problems where the ratio of examples from each class is imbalanced by nature. Imbalanced data refer to the case where the instance of one or more class is much greater than the other class. The general training objective for a classification model is based on the empirical risk minimization principle that minimize the misclassification regardless of the type of error. Following ERM in the imbalance setting could end up with classification model with poor predictive performance on the minority class. Approach for dealing with imbalanced data can be divided into two streams: data level approach and algorithmic level approach. The data level approach normally relies on some data pre-processing step to rebalance the class distribution, and algorithmic level method are dedicated algorithms that directly learn the imbalance ratio from the dataset. Cost-sensitive learning is algorithmic level approach, a supervised learning machine that was developed for classifying data where misclassification may incur different costs. Define different misclassification costs for each data class. Usually, the cost of minority class should be higher than majority class. Adaptive boosting. The non-uniform misclassification cost demanded by class imbalance are naturally fit with the working of boosting algorithm. Other boosts called a giving-based learning algorithm repeatedly in a series of rounds. The weight of training samples on each the iteration always are set equally. To better control misclassification cost for imbalanced data, Sun and author study various variations of cost-sensitive database, namely ADA-C1, ADA-C2, ADA-C3, and ADA-Cost, in terms of their capacity in dealing with the class imbalance problem. They found that ADA-C1 was superior with other variation. First, imbalance ratio. We use this approach to determine the cause. The most straightforward way to set the misclassification cause is probably to use the class imbalance ratio. Let n positive and n negative denote the number of each class. We can define the equation. From the definition, cos positive will larger than 1 when n positive less than n negative. The second strategy performs a git search on the value of C positive while C negative stay fixed at 1. Model selection was performed based on cost-validated performance measurement. We employ the geometric mean of precision and recall as the optimization criteria. The git search length covers C positive between 1 and 2 with 0.05 increment. T4 cost validation was used to select the best C positive. The third strategy stems from the observation that initial data distribution in a boost was set uniformly. That is, initial weight equal to 1 divided by sample size. To give the minority class some focus early from the first round of booting, we propose to assign a non-uniform data distribution in this equation. Datasets and protocol. We evaluate T-cost determination strategy using 5 real-world datasets. We employ prima diabetes, breast cancer, liver, heart failures, and breast cancer of Coimbra datasets from the UCI repository. Each dataset was randomly partitioned into 2 subsets, 70 for training and the remaining 30 for testing. Result: average rank of the algorithm overall datasets that show the traditional other boost which minimize the misclassification cost regardless of the error type in terms of accuracy. It ranked first among all algorithms. Unsurprisingly, it failed to recognize the minority class as reflected by the poor G-mean, F-score, and MCC. Secondly, imbalance ratio strategy seem to overestimate the misclassification cost and result yield a model which is to focus on minority class. Meanwhile, the git search and ADA-C1 improves upon the traditional other boost on some datasets, but is still comparable to other boosts overall. The distribution correction strategy seems to outperform all other strategy in all measurement except accuracy. Interestingly, the git search paired with distribution correction still lag behind using the distribution correction alone. Conclusion: we compare T misclassification cost assignment strategy to be used in cost-sensitive other boost algorithm. Among the strategy tests, class distribution correction outperform other strategy while being more computationally efficient. It is recommended for misclassification cost setting in imbalance learning. Extending the study to multi-class imbalance datasets is an interesting direction in the future.
Okay, thank you for your presentations. Okay, everyone, please open your camera and ask the question. Any question for audience? Okay, I have one question. how can your proposed method is called distribution correction dealing with imbalanced data? Okay, I think this daughter is not here. Okay, we go to the second paper. Yes, the title is toward IoT and data analytics for the chicken welfare using RFID technology. Okay.
Pakawat Julamonthon and I'm from the Department of Control Systems and Instrumentation Engineering at King Mongkut's University of Technology, Thonburi. Today, I'm going to present a research work about a transformer model for stock price manipulation detection in the Stock Exchange of Thailand. First is the introduction and background of this research. Stock manipulation is an activity that misleads price and volume in trading markets. One of the stock manipulations is trade-based manipulation, where the manipulator tries to execute the order that intend to deviate normal price. Figure 1.1 shows the illustration of stock manipulation in pump and dump pattern. There are roughly 5 major events, starting from the normal trading activities. Then the manipulator enter their non-bonafide bid orders, which cause the price pricing.
อันนั้นน่าจะผิดวิดีโอครับตัวที่ 2 ครับผมครับ
investors
Session host ครับน่าจะผิดครับวิดีโอตัวที่ 2 ครับอันนี้ตัวที่ 3 ครับผมครับ
Hello, sorry, I'm the first paper and just recently joined, so I'm sorry.
Yes, we going. What is your paper? What is your number?
I think it's in this. My paper is the E-Node B selection using the channel outcome with machine learning. My paper number ends this with the 98.
Okay, machine learning is the order is number 4. Yes, we on a number 2. Yes, please wait.
Okay.
Yes,
Okay, sorry for that. Okay, thank you.
Okay. ครับผมครับsession host ครับผมครับขอวิดีโอตัวที่ 2 ครับผมครับ
ขออนุญาตค่ะอาจารย์
ครับผมครับ
เป็นของคุณภัควัตน์อะค่ะ
ครับผมครับ
presentation เป็นของคุณภัควัตน์อะค่ะตามที่เปิดเลยอะค่ะอาจารย์
เหรอครับเพราะเห็นว่าถ้าเป็นในส่วนของตัวสต็อกเนี่ยจะเป็นตัวที่3หรือเปล่าครับตัวที่2นี่เหมือนจะเป็นทาง RFID ทาง Chicken ครับผมครับใช่ไหมครับหรือไงครับหรือลำดับผมผิดยังไงไม่รู้เหมือนกันครับตัวนี้คือตัวที่2เลยใช่ไหมครับ
ใช่ค่ะตามที่ได้แจ้งมาลำดับที่2จะลงท้ายด้วย ID 944เป็นของคุณภัควัตน์อะค่ะอาจารย์
โอเคครับขออภัยครับเผอิญว่าทางส่งนั่นเข้าผมนี่จะเป็นระดับที่3แล้วก็ระดับที่2นี่จะเป็นทางด้านพวก RFID เทคโนโลยีครับลงท้ายด้วย RFID เทคโนโลยีครับผมครับโอเคครับไม่เป็นไรครับงั้นตามนี้ได้เลยครับผมครับครับผมครับเริ่มใหม่ได้เลยครับผมครับ
Good morning, I'm Pakawat Julamonthon and I'm from the Department of Control Systems and Instrumentation Engineering at King Mongkut's University of Technology, Thonburi. Today, I'm going to present a research work about a transformer model for stock price manipulation detection in the Stock Exchange of Thailand. First is the introduction and background of this research. Stock manipulation is an activity that misleads price and volume in trading markets. One of the stock manipulations is trade-based manipulation, where the manipulator tries to execute the order that intend to deviate normal price. Figure 1.1 shows the illustration of stock manipulation in pump and dump pattern. There are roughly 5 major events, starting from the normal trading activities. Then the manipulator enter their non-bonafide bid orders, which cause the price pricing. When the price starts rising, other investors bring more purchase. After the desired price, the manipulators sell their stocks and the price drops. Video 1.1 also shows the movement in the limit order book where there is a price drop. And this limit order book, or sometimes we call continuous double auction, is the main window that investor can see in trading stock. The problem is that because we all know that financial stocks can profit from price change, someone has recognized this benefit and attempt to influence the price change through unusual trading activities. The real case pump and dump was reported by Nanex and shown in figure 1.2. This behavior is illegal. We want to detect this. However, the manipulation problem is similar to the cat and mouse game, in which the mouse tries various strategies to avoid the cat, and the cat tries everything to catch the mouse, just like the manipulators who do everything they can do to avoid detection. There are many techniques for detecting manipulators, but machine learning is effective in detecting stock manipulation due to its ability to extract key characteristics from a wide range of manipulation tactics. But in order to keep up with the variation in manipulator strategies, the model and data must be updated on a regular basis. That's why in this work, we aim to explore the effectiveness of supervised learning in detecting stock manipulations, scoping on the Stock Exchange of Thailand with the up-to-date model. We chose the transformer model in this work because it is known as the state-of-the-art model. Going through some literature on the stock manipulation detection, it is usually classified into two types, supervised and unsupervised learning. There are numerous techniques available, ranging from the statistical techniques to traditional machine learning to deep learning. There are also some studies on the attention-based classification, but in other fields. They show the result that it outperforms other traditional deep learning models when using the attention-based model. Nowadays, attention-based transformer becomes state-of-the-art in many fields, such as image and vision, where the multi-axis vision transformer outperforms author's model in the object recognition task, as can be shown here in the red box, and in natural language processing, where the Megatron Turing and LG, which is one of the transformers proposed in MOST 222, is used. Because transformer model is increasingly being used with its superior performance, so we want to use this transformer model in the stock manipulation detection. And next is how we prepare the manipulation data. Since supervised learning requires label data to train the model, but it is very hard to use real manipulation cases because they are very rare. Therefore, it is necessary to prepare synthesized manipulations for training and evaluating the model, which is a normal practice in this research field. There are numerous manipulation schemes in the exchange market, but we mainly focus on pump and dump scheme because it is most well-known investment fraud and mostly found with manipulation. Again, the characteristic of pump and dump can be described as in figure 3.1. So the presence of this pattern is therefore highly correlated with manipulation. According to the Nanex report, there was a short-lived real pump and dump cases on the WAB stock listed on the New York Stock Exchange, as shown in figure 3.2. Within a second, the price increased by 8% before returning down 3 seconds later. It is primarily used as a standard pattern and has been seen in numerous stock manipulation detection works. To classify more, Krenberg and Kemps classify the detection into 3 conditions as initial, balanced, and strict, as shown in table 3.1. Therefore, we have 3 degrees of manipulation and found that the case from Nanex is matched with high degree of manipulation based on the price change. And this is how we prepare the label data. First, we have normal trading stocks, and then we inject the manipulation pattern at random position in order to embed these manipulation activities. And finally, we get the synthesized manipulation dataset for training and evaluating our model. Next is dataset preparation. We have 2 types of stock in this work, normal stock and real manipulation stock. 16 normal trading activity stocks were chosen from the good governance list. For normal stocks, they cover all price range and all market capitalization. Normal stock is further classified as normal 1 for training and evaluating purpose and normal 2 for blind evaluation only. There were only 6 trade-based manipulation cases for real manipulation stocks between 2004 and 2016. The only information available to the public is the name of the stock and the date of the manipulation activities only. For group of a dataset, we have normal 1, normal 2, and real manipulation. We also divide normal 1 into 60-20-20. We inject the manipulation pattern to create training set and validation set. Also, we inject each degree of manipulation in testing set. For pre-processing and feature selection, Video 4.1 shows the limit order book, where it can reflect the market dynamics by displaying changes in price and volume on both the bid and the ask side for each market depth. So we selected feature from this limit order book as a total of 15 features, as shown in table 4.1. All features will be stacked up into a vector of the dimension, which is 15, and later format into a time step. In this work, we use 10-second time step window. For price normalization, we use price rate of change compared to previous time step, and volume normalization, we use Z-score normalization of log transform, simple moving average volume. By data normalization, it helps to standardize the data from different companies, which had different price and volume in trading activities into the same price and trading volume range. Next is the transformer as a detection model. We follow the transformer structure from the KELAS document, which is made up of a transformer encoder and a classification head, as in figure 5.1. However, we modify the classification head slightly to use sigmoid as an activation function for binary classification. Then, as shown in figure 5.2, we stack the transformer encoder box together to increase the model's complexity. The hyperparameter tuning procedure yields the optimal model parameters, as listed here. We also use an early stopping criterion to stop the model training when there was no loss improvement after 20 epochs. And after we have the model, let's now examine the model's performance in manipulation detection. We had 2 experiments. First is the performance evaluation of the model on unseen synthesized manipulation detection. In this experiment, we trained the transformer model with mixed degree of manipulation, as shown in figure 6.1. The accuracy, precision, recall, and F1 score are the key performance metrics, and the results are shown in table 6.1. In detecting synthesized manipulation dataset, the transformer model achieved a total accuracy of 91%, precision of 100%, recall of 82%, and F1 score of 88%. So the transformer model was capable of detecting all degrees of manipulation with reasonable accuracy and high precision. The next experiment is to evaluate the model in real manipulation detection. Again, there were a total of 6 cases during 2004 and 2016 that were classified as trade-based manipulation, and we named it as RM, followed by the number from the RM1 to RM6, as information shown in table 6.2. Because we did not know the exact time in intraday that manipulative activity occurred, we assume all activity in real manipulative stocks during the announced period as manipulation. And to determine how many false positives were generated by the detection model, the detection results for real manipulation cases were compared to unseen normal group 1 and group 2 sets. In this experiment, we trained another transformer model using high degree of manipulation, which is the same price change as the dynamic case. Figure 6.2 compared the ratios of false positive detection to total sample count of 2 models on unseen normal group 1 and group 2. Both transformer models detect very small false positives as illustrated in this figure. The ratio of real manipulation detection to total sample count in the million unit are shown in figure 6.3. It indicates that the model trained with the high degree could detect 3 out of 6 real manipulation cases, as shown in the yellow graph, while the model trained with the mixed degree can detect 5 out of them, as shown in the blue graph. In detecting real manipulation cases, both models missed the RM1 stock. In conclusion, this research explored the effectiveness of supervised learning in detecting stock manipulations using up-to-date model, scoping on the Stock Exchange of Thailand. We prepare various degrees of synthesized manipulation data for training our detection model due to the rarity of real manipulation cases. We evaluate the supervised transformer model and discover that it can detect all degrees of synthesized manipulation, as well as 5 out of 6 real manipulation cases prosecuted by the SEC, with a low false positive rate. For future work, we may further study on the effect of various manipulation patterns in model training to the detection performance. Thank you for your listening.
Okay, thank you very much for the interesting research. Yes. Any question from audience? Any question? And the author of this paper is here.
Yes.
Okay. Yes. Oh, thank you. Yes. I have one question. Yes. What is the limitation with using transformer model in your research?
Yeah, the limitation of this transformer model is it is a supervised learning which require a label to train the model. It means that if we not find the label coverly to cover our trading activities that manipulative, it would cause the model not detect much.
Okay. Yes. Okay. Thank you very much. More question? Okay, thank you very much for your presentation. Yes. Okay, we go to the next presentations.
Good morning, everyone. I would like to present retail management using product classification on a mobile application. May I introduce myself? My name is Somnuk Sinthupuan. Now I'm a lecturer at the Computer Science Department at Major University, Chiang Mai, Thailand. I will begin by introducing the following topics by discussing original retail issue at first, and then how to compare 5 models as a part of the implementation model, how to analyze and design application on mobile using Flutter, and show the result from comparing models, testing mobile application, discussion and conclusion in the final part. In Thailand, we have a small business in every village where everyone can buy anything they need to use in their life. We can call a retail store. Almost all the original retail stores in Thailand were managed for buying and selling by their owners with no need staff support in the small site. A retailer will buy any items from a market near their home or at the moment from macro shopping center and distribute them throughout the village. The list of a small retail store is the number of new convenience stores opening near the community and increasing demography. Customer behavior change because most people have smartphones, so the living behaviors and social structure change. How to compare with a modern retail store like 7-Eleven? We are thinking about the machine learning for mobile application, model preparation, and best model implementation. We implement by comparing and selecting the best result from 5 pre-trained models, which includes MobileNet V2, VGG16, CNN, Inception V3, and ResNet. To develop mobile application, we prepare data with our students by manually 32,000 images for 32 times, and then divide data 80% for training and the other 80% for evaluation model, where each image will be rescaled to 222 in width and height, and normalized by divide with 255 to adjust the rank of image less than or equal to 1 before compiling, training, and evaluating model again with a sequence model as shown in this link. For mobile application, we have implement a mobile application by using UML for analysis and design the application. This slide presents an example, only use case diagram, which consists of two actors, a retailer and a consumer. A retailer can manage stock and update product quantity, and a customer can buy and view products using product classification. We design a mobile application user interface for consumer and retailer corresponding with use case diagram. For database, we develop mobile application by using Flutter and a database on cloud computing. We select Firebase on cloud to be a database because it has no SQL and easy to manage with the Dutch language on Flutter. This slide shows an entity relationship diagram of a table in our database because it is easy to understand. But the database in Firebase is represented in JSON format. ER represent consumers who can buy a product into a basket. And then they confirm the order and payment for product in the basket. A retailer can manage stock of product and payment. This table shows the result from experiment. The result from experiment found that the MobileNet V2 has the highest accuracy and validation, 0.996 and 0.92880 respectively, which is shown in the table and chart when compared with 5 pre-trained models. From the experiment result, we found overfitting problem. We found that when you look at the table, we found that CNN and Inception V2 have overfitting problem because we found a gap between the result of accuracy and validation from the experiment of CNN and Inception. 0.4217 and 0.5028 respectively. We have solved this problem by using data augmentation to reduce a gap. The result found the CNN has reduced a gap to be 0.011. The result from mobile application testing. We use a mobile application which has developed from the base model with 3 sources to manage retail stores. We found that every retail store can use our application to manage stock sell a product and pay more easy when compared with the original retail management. After collecting and pricing, which has sold product for 6 months, we found that the retailer one has the highest number of products sold in the first month, and the retail 2 has the highest number of product sold in the 6 months, and the retail 3 has the highest number of products sold in the 4th month. When we compare with 6 months previously, we found that the average price was greater than about 1% point, 5% point, and 3% point respectively. In conclusion, we found that the model with the highest accuracy and validation was the MobiliNet V2. The accuracy and validation values were 99.96 and 92.82 respectively. In the experiment of the mobile system with 3 stores within major city, we found that the system could be used to manage retail store. Finally, may I say thank you for your attention.
Okay, thank you very much. Any question from audience? Any question? Yes, Professor, I have one question. Yes, how do you deal with your overfitting concern?
Yes. After I look at the result from our experiment, we found CNN and Inception V2 have gap. We prove gap analysis by using data augmentation by learning testing again. It can be solved this problem.
Oh, it's very nice. Oh, okay. Okay, thank you very much, Professor. Yes. Okay, we'll go to the next presentation. Yes.
Thank you so
Session
much.
host. Thank you, Professor. Yes. Next presentation.
Good morning, everybody. Chairman, all conference participants in this presentation room. I'm Anand Manku, Master Degree student in Data Science from College of Digital Science, PU, Thailand. Today, I would like to present an article, the topic, performance of a loan repayment status model using machine learning, which is part of the research on the topic, model for predicting loan repayment ability, a case study of Asidic Islamic Cooperative Limited. For the content to be presented in the following order: introduction, objective, related work, methodology, result and discussion, conclusion, future work, and reference. Okay, the first Asidic Islamic Cooperative is what the first Islamic cooperative in Thailand was established in 1994. Currently, the cooperative has 7 branches providing financial service to members of the cooperative, such as members share, wadi'ah, or saving deposits, mudorabah deposit, joint investment, loan, and welfare service. The cooperative has 25,151 members a total of assets more than 1,661 million baht and 4,922 loan contracts per year. It was accounted for 1.72% of the total loan amount, which up to the 355 million baht per year. In 2019, the cooperative recorded bad debt and doubtful debt of 6.2 million baht. Therefore, the purpose of this study was to model the loan repayment status of the cooperative member using machine learning technique. For the purpose of this article, to investigate the model for predicting loan repayment status of Asitic Islamic Cooperative Limited in Songkhla province. Next slide. To related work, the author has summarized, analyzed, and synthesized previous article related to financial credit, which are on loan repayment ability, loan approval, or debt settlement were modeled using machine learning. From the synthesis of previous slide, the analysis of financial credit data, which the loan repayment ability, loan approval, or debt settlement provide accurate value. This includes random forest, decision tree, and logistic regression. Slide 2, methodology, data, and variable. The data of a current study were obtained from Asitic Islamic Cooperative Limited, Songkhla Province during 2014 to 2021, a totaling of 15,314 observations with 17 independent variables. The dependent variable of this study was loan repayment status, which was a binary classification defined as good and bad status. The dataset were prepared as training 70% and testing 30% of the datasets. This table is an independent variable. For this slide, is a part diagram for this research, which before preparing the data for training and testing. The researcher performed data manipulation or data management, cleansing data, check the proportion of each group for each variable and data recouping, and then bring it into the feature selection process to select the feature or characteristic or variables that are most related to the dependent variable as appropriate by using feature selection technique. The following information can Gini index and transfer test, and then bring it into the model performing three techniques are decision tree, random forest, and logistic regression, and then evaluate the performance of model, including accuracy, precision, recall, F1 score, and AUC and IUC curve. Okay. The result obtained from research study and experiment initially from 2014 to 2021, 2021. The loan repayment status of the cooperative member were registered as good with the number of 6,526 credit contracts, representing 38.66%. They are registered as bad with the number of 8,778 credit contracts, representing 61.34%. And then this slide, the result of feature selection are shown in this table for the information can and Gini index. Most the important factor where the same such as a cooperative brand, loan object, members age, monthly payment period, loan amount, age of membership, and gender. The independent variable were demonstrated from the three techniques that associate to the loan repayment status where cooperative brand, loan objective, member age, and previous loan amount. This all is the performance comparison of three models are illustrated in table 3, table 4, and table 5. The accuracy of the three models were less than 70%. The result of the study found that the highest performance was the model of decision tree with the accuracy of 63.1%, followed by logistic regression and random forest with the accuracy of 60.9% and 60% respectively. This picture, the ROC curve show in the decision tree model with the highest area under the curve of 0.63. Random forest and logistic regression as area under the curve of 0.59 and 0.57 respectively. In addition, when area under the curve greater than 0.5 and less than 1, there is a high chance to distinguish the loan repayment status as good or bad. Conclusion: to sum up of the current study, the most efficient model was decision tree with accuracy of 63.1%. The logistic regression and random forest gave no big difference in accuracy at 60.9% and 60% respectively. The efficiency of the model was less than 65%, possibly due to the problem of the data imbalance. The frequency of loan repayment status for each group versus each group of the determinant were quite different. Future work, ongoing work, the auto machine learning method will be fitted to the data such as a convolutional neural network, CNN, support vector machine, K9 classifier, naive Bayes, and XGBoost classifier. Dealing with imbalanced data may require a focus. This reference. Let me finish this presentation. Question or suggestion, please ask or make suggestion.
Okay, thank you very much for this presentation. It's very interesting. Yes. Any question? Any questions from audience? Okay. Professor Anon, are you here?
I'm here.
Oh, okay. Yes. I have one question. Yes. In your feature selection process, what is the Gini index? I mean, what does it work? Gini index.
Any index?
Yes, yes. What it is?
In Gini index, I select important value from all variable.
Oh, it's work like the filter. That's right. Filter, maybe a data filter or something like that. That's right.
No.
Okay.
Gini index, I select feature important value. I has 0, 1, 1.06 up.
Oh, okay. Okay. I think. Okay, I understand. It means look like a threshold value or something. Okay. Yes. Okay. Thank you very much for your presentation. Yes. Thank you.
Thank you.
And okay, we go to the last presentation.
Good morning, everybody. So today I will present the research paper titled Toward IoT and Data Analytics for the Chicken Welfare using RFID technology. My name is Greta Passieri. I am Associate Professor from the Department of Computer and Information Science, the Faculty of Applied Science, Kim Il-sung University of Technology, North Bangkok. The rest authors are my student. So this research paper is a senior project. We got the research funding support from Takahashi Donation, Mini Bear, Mitsumi Limited. So in this talk, I will start from motivation and research objective. The second, I will introduce about research methodology. There are several steps, like for example, I have to survey RFID technology for poultry farm, and later we design software architecture, and we perform the experiment for food intake tracking. And the rest topic is conclusion and future work. The motivations of this research come from the idea that we want to help the farm owner. She has the poultry farm. This farm provide breeding chicken. So the farm sell the fertile eggs to the market. She's complained that in the farm, the chicken is usually sick. So we think about animal welfare. The animal welfare may refer to good feeding, good housing, good health, and appropriate behavior. So in this research, we focus on good health because the chicken is usually sick. So if we can develop the software that support farm management and the chicken is reduced, it will be good. And another topic, we want to apply IoT devices for data analytics. So we think about tracking food intake because the farm owners say that if the chicken may be sick or maybe inactive or not pick the food from the feeder, it may be because the chicken may sick. So if the farm carer can detect the chicken, that may be sick earlier, the loss from their dying can be reduced. So this slide shows the research methodology. There are 4 things that we do in this research. The first one, we design software architecture. Because this project involves the devices, RFID devices. So we have to find the best solution to use in this work or to experiment. We have found that there is no special equipment for health tracking and behavior tracking. But we found that there are only RFID rings for identifying the chicken. The second step, we gather software requirement from the farm owner. The farm owner want the software that support farm management and health monitoring. And the third step, we develop software application. In this work, we develop mobile application and web application. These application support farm management and also data analytics. We consider about further technology and web technology, and we choose these 2 technology together for software development. And the last step, we conduct an experiment about food intake using RFID. So we survey RFID technology for poultry farm. We survey the equipment or devices from online market. For example, we survey from Alibaba website, and another one is Lazada. But many devices are provided in Alibaba. So we order some for our experimentation. Here, there are RFID rings. The RFID ring for chicken identifying, there are different sizes. And for RFID reader for chicken identifying, there are different equipment. Some equipment can use with the mobile. Some equipment can use with the computer. And some, like for example, RFID handheld, you can carry and to check, to identify, to read the information from RFID ring. And the left-hand side is RFID reader that must be installed. Like we call it is a stationary RFID reader. So this slide we show software architectural designs. The user in this project are 2 types. There are the farm owner and the farm caretaker. The farm owner can use web application to manage her farm, and the farm caretaker can use mobile application to during her time of working. For example, to identify the chicken. For example, we want to know how old is it and what is breed of the chicken, or what the drug the chicken are taken. So in this architecture, we use Firebase as the database. So it means it's a JSON database. So this slide shows the use case of software application. And the left-hand side is for mobile application, and the right-hand side for web application. For mobile and web application, they have similar function. Some are similar, some different. Like a farm owner can create a coop, can view the coop, can observe observe list. Observe list is mean the chicken that may sick, something like that. And can view chicken statistic, how many eggs they get from the farm in each day, how many chicken in her farm, or about sex and how age are it. and she can add a chicken into the coop. And some use case regarded to tracking behavior, and some use case regard to drug taking. For food intake tracking, we perform a small experimentation. So you can see in this video, we assume that if the chicken walks to the feeder, we assume that it will eat. So the IVD reader should read the signal from the IVD ring. But we have found that the chosen IVD ring is not suitable for tracking because reading signal is difficult. And some chicken walk around the feeder but not pig. However, IVD reader can track active or inactive behavior, but we can't assume that it picked the food from the feeder. Therefore, analytics reader, they are sick because of not eating may be impossible, but because of inactive is possible but lacks the precision because of reading signal is difficult. This lecture are data analytics. We observe for 7 days from 6 a.m. to 24 p.m. But from 24 p.m. to 6 p.m., the light is turned off, so the chicken are asleep. The number of read data show like in this slide, and we have found that in average, it's about 555 lines per day. One line is one reading signal. Or when we divide by 25 chicken, it's about 22 lines or 22 activity per one chicken. So it seems like it's so small. So we think that reading signal is not so accurate. And sometimes the IFD rewrite can read duplicate signal, something like that. So from this research, the software applications is under development and it will finish soon because it's senior project and they have to take exam in the end of this month. In the end of next month. We found that IFD technology is not cheap for poultry farm. Like for example, if you want to track the behavior by using IFD reader, like stationary, and you have to put into the coop, that means you have to pay more. And also using IVD ring, the chicken are different in sizes and therefore they need different IVD ring size. Tracking active or inactive behavior is an interest topic. However, cheaper equipment are preferred. Model for reading IVD ring may be placed in the coop and in different zones, for example. Thank you very much for your listening.
Thank you very much. Okay. Question.
I have only one question.
Oh yes, please.
I see your research grant. Have you ever to any industrial project with the research grant owner or with author? I think this one is very interesting, right? To apply for IoT and also of your record data to author.
Sorry, Professor Dashkon, it has an echo.
Sorry, I use the mobile phone. Okay. Just only ask the industrial project that you have before.
What do you mean? Are you interested? I don't understand the sound is so echo.
It's no problem. Thank you.
Well, thank you very much for that. You can chat with the room message. Oh, yes, please. Yes, please. Question.
Yes, I would like to have a question about the data analysis that you did. It says 7 days seasoning. Would it be possible if you use a wider range of data sets?
Yes.
Okay.
You can explore area you want. If for 7A, so it's not different. Specify.
Do you find any valuable insights from that? And would it be different in different seasons? For example, like rainy season.
Maybe,
But
but
season.
my experiment reading signal is the problem. So I think if you don't solve that first, doesn't matter. You will experiment. Do you understand? You can extend, but you have to make sure that the equipment good.
Can audience understand with this answer?
Due to the echo, I cannot hear clearly.
Yes, me too. Yes, that's an echo. Yes. Sorry for technical error. Yes.
Thank you for your answer.
Okay, thank you very much. Okay, we go to the end of this session. We will break 1 hour and we go continue the conference in 1 p.m. Don't forget to join our room. Yes. Thank you for your contribution. Thank you very much. สวัสดีครับ
สวัสดีค่ะ
Okay, guys, I think it's time for our session today. Firstly, how about your lunch? So, welcome all of you guys, presenter and audience, to the session of the 19 ECTI conference. This is room number 3. Our rules is host will open the video for each paper about 15 minutes, and we will have 3 minutes for question and answer. The session will start about 1 p.m. and finish about the 2 p.m. and 15 something. So I will introduce the first paper to present the knowledge, This is the first paper, the time-sensitive hashtag frequency inverse hashtag ubiquity algorithm for hashtag recommendation in Twitter. The presenter is Changi Gu. Please welcome.
Let's start my topic. My topic is time-sensitive hashtag frequency inverse hashtag ubiquity THFH algorithm for hashtag recommendation system in Twitter. So let's talk about Twitter. Nowadays, social media has become a more important part of people's life. Since Twitter is one of the social media, and people is more like to understand what's happening in the world through social media. In 2021, there are 192 million daily active users on Twitter and 500 million tweets posted every day. For hashtag is one of most important feature in Twitter, and hashtag is a combination of keyword or tokens that start with symbol hashtag. Twitter user may add one or more hashtag for specific topics. Hashtag recommendation system. As we know, most social media like Twitter or Facebook will recommend a topic to user based on their interest and relevance. Also, there are several challenges. Most tweets were initial with 140 characters, means it is smaller, low data compared with traditional one, and the content of tweets is unstructured, which can be hard to pre-process and analysis with many noises. And the data is very huge due to it is real-time streaming data, so it is hard to process it, and it's hard to correct the data. HFIHU hashtag frequency inverse hashtag ubiquity. This is the original hashtag that we can improve and enhance. According to our observation, to find the best hashtag for user, it is insufficiency to depend on these features of interest. Also, we can add more features based on the time feature and the tweet length. So we plan this part to enhance the HFIHU. The scope of work we proposing THFIHU algorithm. This is enhance the HFIHU algorithm to address time-sensitive hashtag by adjusting hashtag weight by the time-sensitive factor and using tweets length and labeling terms and hashtags to calculate the new weight. Also, we collecting, clean, and pre-processing the dataset before applying the algorithm. And we prefer a comparative study on proposal algorithm, THFIHU and HFIHU original algorithm to compare their performance in terms of recall of time-sensitive and time-insensitive hashtag retrieval. Also, we creating a Python-based hashtag recommendation program to demonstrate the use of the proposed THFIHU algorithm. For some review, in early research, there are some papers focus on sentimental classification for hashtag recommendation system, and many works focus on use TF-IDF as based methodology to calculate the weight. Song and Mun proposed a new approach to classify and ranking hashtag by analysis the category. And also some researcher introduced hashtag graph-based topic module HGTM, which used to link the hashtag relation graph as features. As we know, TF-IDF is a commonly used weighting technology for information retrieval and data mining, but TF-IDF is not very practical for Twitter, like a macro blogging system. So there are some challenges and some strict rules. So HFIHU, like an original algorithm, is proposed to solve the problem. And we also can find some limitation regarding HFIHU. This algorithm didn't consider the time effect, and also the tweet length is another effect may impact the final result, and the max frequency of hashtag and token value will be unlimited. This is not useful. So we can expect HFIHU. Let's introduce first. HFIHU is a ranking schema. Is like a design from well-known TF-IDF that consider hashtag relevancy and data sparseness. It creates a mapping structure between token and hashtag THFM and HFM. As we can see here, for example, there's two tweets: basketball game at New York, hashtag NBA, and game Battlefield, hashtag PS4. As we can see, NBA is 3, we get NBA 1, MBA 1, PS4 1, PS4 1. This is separate, and another MBA 1. This is THFM, and HFM, and we can sum it together like an MBA. It appears 3 times, so it counts as 3, and PS4 counts as 2. And that's 2 parts. So firstly, let's talk about HF part. THFM, as I said, is denote the number of accuracy of hashtag with token T in the corpus. And THFM is sum of all hashtags frequency related to token T. Therefore, if this is a result to measure the relevance between a token and a hashtag. In conclusion, if more users use a hashtag with specific token, this hashtag is more related to this token. And the downside is HIHU part, where corpus NH, it denotes the number of all tokens in corpus after hashtag are removed. And the HFM denotes the sum of all tokens frequency related to hashtag T. So as a hashtag H is associated with most tokens in corpus, this score will decrease. And we multiply 2 parts and get the final score, and add together to get the final score. This is the steps. Firstly, we get a tweet, and we like a map THFM and HFM, and we apply the value into the algorithm and sum together to get the final score. Let's introduce another algorithm, best match 25. This is algorithm to enhance THF IDF. Unlike TF IDF, BM25 add constant K to limit the TF value, as we can see here. The TF value in traditional TF IDF will be infinite, and the score of BM25 for TF value between 0 and K plus 1. Also, they add the ratio of document length to the average length. This means we consider the length of the tweets of the documents together to adjust the weight. B is another parameter to adjust the punishment of score, and K is another adjustment parameters to adjust the alpha of token frequency. And alpha beta is used to avoid log 0. And the alpha is used to deduct the punishment score of document length. And let's talk about our proposed methodology. We separate by 4 steps. First step is pre-processing data. In order to reduce data set, we remove all tweets without hashtag and some tweets with error code. Also, remove unrelated attribute of tweets manually. And we do the data processing by following step: removing punctual and non-alphabet symbol, removing common stop word, and transforming all text to lowercase and stemming. And we separate by 4 steps. Firstly, we collect the terms dictionary and hashtag dictionary. Then we scan a database and list all months that term and hashtag posted, and we label the hashtag and the terms in range of 1 to 12. 1 represented by January, 12 represented by December, and set a month count. Let's count how many months appeared and store all labels into dataset. So this is steps like same as the HFHU, as we can see here. Give a twist and we get the label terms and retrieve THFM and HFM. And finally, we apply, and this is value we get from the label. And finally, we get the final answer with the time ethic. And this is the result. This is compared with the original one. We set as top 10. As we can see, result like it is increased significantly between 1 to 13 ranked hashtag, and it is the proposed algorithm THF-IHU outperformed 10 to 50% over original one. And for recall, it has increased a lot, like 11% to 50% of recall increased. And we can see the improvement. And when we recommend the first hashtag, it increased around 35% in terms of the recall. This is the increasement rate. And this is the reference. Thanks for your watching.
Okay, thank you very much for presenter. And this is a time for question and answer. Who have a question, please? Okay, one question, Shanky Gu, one question. You said like the algorithm can improve like over 35% in terms of the recall. Do you have the plan for the future to improve the more correct? I mean, improve the percentage of the correct one. Do you have a plan for the future work?
Yes, I have plan for the future work since right now I only focus on the month. So basically, based on my research, if I focus in different time units, such as day, weeks, or even hours, the result should be adjusted different. But for different time hours, time units should be like spend different time to calculate. Because if we focus on hours, maybe need to spend more time to calculate the result. This is for my future study.
Good. It's a good idea. Thank you very much again. So, who have a question? If all of you guys don't have a question, we will go to the second paper. The paper is Drop Quest Game-Based Learning for Chemistry. I'm so sorry, who is the presenter for this? Kun Thirawat, right? This is a Drop Quest Game-Based Learning for Chemistry. Please welcome for presenter Kun Thirawat Kanchana Phanwong from Faculty of Information Technology, Lat Krabang.
Yes.
Yes, you can play the video.
My name is ROOM3 from the Faculty of Information Technology, KMITL. Today, I will present our work called Drop Quest for Chemistry, a game-based learning for chemistry. First, I will start from introducing our work, then I will briefly explain our system overview. After that, I will show you the demo of our game, followed by several experiments to evaluate our game. And finally, I will conclude our work. Let me first tell you why we are working on this problem. As you may already know, chemistry is fundamental knowledge which is crucial and strongly related to our daily life. Although we have spent years studying chemistry in school, the traditional teaching method failed poorly. As you can see from the average score of chemistry tests from TCAS exam last year is only 29%, and the number from the last 5 years are equally bad. Recently, there are many attempts to integrate the game-based learning method into school to increase student motivation for learning. Thus, in this work, we propose a game-based learning mobile application called Drop Quest as an alternative tool for reviewing chemical elements and the periodic table. Drop Quest is a physical-based competitive brewer mobile game which aims to increase student motivation for learning as well as their knowledge about elements and the periodic table. Here is the overview of our game. Drop Quest supports both single-player and multiple players mode game. In the game, students can either create a new room or join an existing room to play the game. Students can change the setting of the game, including the topic of question they want to reveal, the number of questions in the gameplay or the map that they want to play. In each round of the gameplay, a question and multiple choice answers will be displayed, as well as the answer block that will randomly appear around the map. The round will end when all the answer block is thrown into the answer pit in the center of the map. The player will receive the score if the answer is correct. Otherwise, the score will be deducted. There are also a tutorial mode for new player, as well as the interactive periodic table for students who want to quickly review the topic without playing the game. In this work, we create a novel dataset called the Quiz dataset. The dataset contains more than 600 questions about elements and periodic table across 6 topics such as atomic number, element symbol, element period, benefit of elements, element name, property of elements, and the example questions are shown here. These questions are taken from the chemistry book, and it will be randomly selected displayed into the gameplay. Now, let me show you the demo of our game.
To start the game, one player has to be a host to create a room for other players to join. This room can be joined among players in the same network. New players can either join existing room or create their own room. Players can join an existing room by clicking confirm to search for a room. After entering the room, player will appear in the lobby or waiting room. The game will start after player have joined the room and click ready. Gameplay in each round of the gameplay. A question and multiple choice answers will be displayed in the pop-up window. These questions are randomly sampled from the .quest quiz dataset, which includes 600 questions from 6 different topics about elements of the periodic table. Each answer is represented by the symbol in front of them. This symbol box will be placed in the map.
The round will end when time out. The players will receive 10 points if they throw the correct answer box into the pit. Otherwise, their score will have 2 points deducted. Since there is only one correct answer in each round, players have to battle each other to get their hand on the correct one. To encourage players to participate, quickly those who do not answer the question until timeout will lose 5 points. At the end of each round, the score summary will be shown. The gameplay ends when players complete 5 questions, and the scoreboard will be displayed.
To evaluate our game, we explore several experiments. We would like to evaluate the quest in 2 aspects. First, its performance as an effective alternative learning tool for elements and periodic table. and second, its performance as an enjoyable game-based learning application. To do so, we conduct several experiments comparing DubQuest with two baselines. The first one, Teachable website, an interactive website which offers rich interactive information about elements and periodic table. The second one is the Element Flashcard game, an educational flashcard game for players to revise the elements and periodic table and how they combine to form the world around them. First, we evaluate DubQuest performance as an alternative learning tool for the elements and the periodic table. To do so, we conduct an experiment, compare DubQuest with P-Table, the web-based learning baseline. This experiment includes 10 participants whose average age is 21. These participants will first complete the P-test exam. Then we split the participants into two groups. The first group consists of 5 people who only review the periodic table while learning from P-Table website. And the second group of the participants is the game-based group who only review the topic while playing DubQuest. So both groups will have about 3 days to review the topics with the different method. After that, both groups will take the post-test exam. The pre-test and the post-test score from both groups are shown in the table. Although both groups achieved better scores after the studying period, the score revealed that P-Table outperformed DubQuest by improving the performance of the participant about 20%, while DubQuest only improved the participant performance about 7%. We think that P-Table is designed as an interactive web-based periodic table which offers elements basic characteristics as well as in-depth knowledge and relevant subjects. Unlike P-Table, the objective of DubQuest is to be an entertaining and informative educational game where players could improve their performance while enjoy playing the game at the same time. As the game achieves its objective by enhancing the performance of the participant about 7%, we posit that the gap between the baseline and our game is a trade-off player enjoyment that is unavoidable and acceptable. Next, we explore DubQuest performance in terms of informative and entertaining tool for reviewing elements and periodic table. Thus, we survey the degree of satisfaction of the 3 systems by several criteria. The participants are asked to rate P-Table and board game on several criteria scoring from 1 to 5, where 1 means hate it and 5 means love it, and the results are shown in the table. From the result, DubQuest gets the highest score in interest and enjoyment. However, due to the complication of the gameplay, we get the lowest rating in terms of ease to use and smoothness. However, we did pretty well on informative and appropriate content integration. Thus, we achieved the best average score from all criteria. Now, let me conclude our work. In this work, we propose DubQuest is an alternative tool for reviewing chemical elements and periodic table. There are at least 600 questions across 6 topics in the game. The experimental results confirm that DubQuest provides both enjoyment and knowledge about elements and periodic table. Although the game still has some weakness, it nevertheless achieved the highest average satisfaction score compared to the baseline. Thank you for your kind attention, and we're happy to answer all the questions that you might have.
Thank you for the presentation. It's time for the question and answer. Who have a question, please? Okay, just one question. Due to the application is very interesting, so I want to know, do you have any obstacle or barrier or difficult issue when you develop the game-based learning? Please share the idea.
Hello, can you hear me?
Yes, I
Okay.
can hear you.
So sorry for that. So yes, we have several obstacles during development. So the first one is that since we trying to develop the game-based learning as the alternative tool, right? So as you can see from the experiment that we would like the game to achieve a better performance on improving the participants' performance on increasing their knowledge. That doesn't turn out that well because we think that that's the trade-off, that we have to make the game more enjoyable for them as well. So I think the thing that when the game is enjoyable, like people fighting on each other trying to get for the correct answer, is kind of like distract them from what they have to learn as well. So we're trying to find the balance between that, and it's quite hard right now. But yeah, that's one issue that we found on the development.
Okay, this is a challenge. So
Yeah.
I support for you guys to extend the experiment or maybe the game base to be more interesting. This is a very good idea, the quest. Okay. Thank you very much again for the presentation. So we will move to the third paper. Thank you very much.
Thank you.
Okay. For the third paper is a non-entity approach for intent-based classification, a case study of Thai news. Please welcome presenter Kun Chayanan Damrongrat from NECTEC.
Hello everyone, my name is Chayanan Damrongrat from NECTEC, a research organization in Thailand. I would like to present our research, a non-entity approach for intent-based classification, a case study of Thai news. In general, we classify articles, for example, news articles, into categories such as economic, politics, and sport. We normally categorize an article based on its content using its important entities such as noun and verb. Let's define this classification problem as content-based classification or CBC. What happens if we categorize articles in different point of view? Assuming that we have the same articles, but we categorize them based on the intention or purpose of the editors instead of using the content itself. For example, categorizing the news article into the information level like inform, explain, and solution. When the inform means the new article providing only fact of what happened. Explain means the article provides reasons or explanation, and solution is when the article gives a solution to solve the problem. Let's define this classification aspect as intent-based classification or IBC. Regarding to these categories, do these entities still play important roles for the classification? I think maybe not. because intent-based classification is kind of context understanding, not content understanding anymore. We also have a hypothesis that terms that represent or link the relationship between words or phrases in the paragraph may play more important roles in this case. For example, the term because. Normally, we may consider it as a stop word and ignore it. But in this case, the term because is a hint to relate to the explanation or reason, and it may have a strong relation with the explained categories. We propose this, the use of the linking terms as a key feature for the classification as a non-entity approach. Based on what we have said so far, in this paper, we have two hypotheses. First, intent-based classification or IBC tasks require a new approach to handle the problem or not. Second, our proposed non-entity approach, can it handle the IBC problem? For the first hypothesis, does IBC problem require a new methodology to solve the problem or not? The experiment is a classification performance comparison generated by two different datasets representing two CBC problem and IBC problem on the same classification pipeline. The first dataset is belong to traditional CBC tasks. There are titles of topics in web box named Pantip. We use the forum names as their categories, which are economics, cosmetic, and food. The second dataset is IBC tasks. There are news articles from new organization named Thai PBS, who are our partner in this research. The new organization provides staff to label articles into three categories: inform, explain, and solution. Each category represents the intention of providing information level, whether the news article providing the facts or what happened, give an explanation or reason, or give a solution in the article or not. In this paper, we experiment with 6 different classification methods, range from traditional statistics, shallow neural network, to deep learning. We use MCC or Matthew correlation coefficients as our main evaluating metric. It is a standard metric for multi-classification, since its ability to overcome the bias of imbalanced dataset better than the other metrics. In this experiment, the results show that CBC is outperformed the IBC for all classification methods. It is confirmed that the IBC should be solved somehow differently from CBC. Moreover, if we look closely to IBC score, they are quite low and it needs to be improved. For the second hypothesis, we would like to check if our proposed non-entity approach could be benefit to the IBC problem or not. We start with the IBC problem and then we process the data into the 3 different datasets. The first 2 datasets is the traditional one. The first one is a full text dataset. Second one is the entity-oriented dataset. And the last one is our proposed, the non-entity dataset. We simply use the POS tagging to define which term is entity and which term is non-entity. The entity could be noun, proper noun, verb, adjective, and non-entity could be mainly to the conjunction, verb, particle, and so on. Before we go to the experiment result, let me explain what is the meaning of the bold text and the underlying text to reduce the confusion. At first, the bold text means the highest score among the 3 datasets, the full text, entity, and non-entity, while the underlying text is the highest score among 2 datasets, entity and non-entities. Okay, regarding to this table, the results show that the full text dataset can provide the best performance among 3 datasets, full text, entity, and non-entity, in almost all classification methods. Then how about our hypothesis? The use of non-entity approach that may be benefit to the IBC task over the entity approach. Let's see here the underlying score. We can see that our hypothesis is partially confirmed, but only on the statistic-based model. I think our hypothesis is sound on this statistic-based model because the model is simple and is straightforward. But the reason why it does not work on the neural network-based models, we need to investigate more in near futures. At this moment, we don't have a valid assumption yet. However, my opinion is it may rely on the pre-trained models, which are full text. It might be able to capture some meaningful information for IBC tasks. Another interesting issue, we found that the neural network-based methods performance are much worse than the statistic-based method. It's like a 0.2 versus 0.5. Why? We have hypothesis. The neural network models always use the pre-trained that's always made by the full text content, while our dataset, both entity and non-entity, is dataset that rely on the removing some text off that might have some impact. And another hypothesis is the neural networks is always require large dataset to train a model. But our dataset is approximately 1,000 for each category. In conclusion, this paper tried to view the classification task in different point of views. In this case, intent-based classification or IBC. We have a hypothesis that the IBC should be handled differently from the CBC. We also propose a non-entity approach to handle the problem. The experiment showed that it's confirmed that IBC needs some different methodology to solve the problem. However, our proposed non-entity approach is partially confirmed. It works as expected only for the statistic-based classification methods. IBC problems still have some room to be improved since the model can predict its base at 50% only. Thank you.
Thank you very much for the presentation. This is one of the good, interesting paper. So, do you have a question? Okay. One question. Did you try the Thai news in Thai language or English language?
In this study, we use Thai language.
This is a good. Do you have a barrier when faced about the Thai language? Because as you know, Thai language is very challenging for the NLP.
Yes. One thing that I think is could be improved in the near future, I think is about how to select entity and non-entity. Because in this study, we use POS tagging. And POS tagging in Thai language, mostly based on the corpus that the content is related to the formal language. And the correctness, when we look in the detail, the correctness is kind of a bit off sometimes. Then if the prediction is incorrect, it will have big impact to the corpus that we created dataset.
I understand. This is a very challenge. We have many slang, right?
Yes.
Okay, good. This is a good paper. So thank you very much for the presentation again.
Thank you very much.
Yes. So we will move to the fourth paper. The paper, namely collaborative filtering approach for movie recommendations. Please welcome presenter Siti Raisa Haran from Faculty of Applied Science and Technology, University Tan Hussein. Please welcome.
Hello, Assalamualaikum, and hi everyone. Today we're going to present our paper entitled Collaborative Filtering Approach for Movie Recommendations. First of all, recommendation system have shown to be an effective way to resolving the problem of information overload. Data in such large amount is frequently unreliable and it is not discarded if it is not properly processed. Researchers have devised recommendation system to address these issues for improved search results. A recommendation system looks for similarities between products and is very popular across a variety of fields. Movie recommendation systems are designed to help movie lovers decide what film to watch. The recommendations are trustworthy because viewers are connected at a very personal level, sharing their feelings from watching the movies. This approach gathers individual movie rating before recommending prospective films to target customers based on those ratings. For example, the Netflix recommendation engine (NRE) is a collection of algorithms that filter items based on the preference of each individual user. Amazon, LinkedIn, Spotify, YouTube, among another website employ recommendation algorithms to anticipate customer interest and grow their business. In situations or domains where items outnumber user, item-based techniques are applicable. Item-based recommenders make a recommendation by evaluating an item or a service to the description of the user's interest. Thank you. In this study, we will use the movie lens dataset with 10,329 movies arranged according to the movie ID. And from the movie ID, there are two types of data, which are the movie title and the data of rating movie. Next, before starting the analysis, the pre-processing data will be conducted to ensure that the data is valuable and usable for further analysis. The data will be stored and also extracted in R software, as R will be used as the platform for the analysis. In data pre-processing, the metric of movie will be conducted to act as the recommendation system that consists of two entities, which are the movie title and the movie ID. The movie ID, which are the user, and it will use to assume the genre enjoyed by the user. The next metric will be conducted to be used afterward to ease the process of movie searching by the genre. And to be able to create the scattered metric, the class that will be used in R is the real rating matrix. At the end of the data preprocessing, several libraries and packages will be installed for the analysis. The packages and libraries are the recommended lab, ggplot2, data.table, and reshape2. The collaborative filtering will be conducted by using the package of recommended lab in R. This package usually will be used to conduct the collaborative filtering process. This method is used to suggest the user's good and other users like-minded have previous preferred or suggest the movie. Lastly, the data will be visualized as the number of views of each movie will be arranged and organized in table form and sorted from the most to the least movie views by using the data.table. Next, the library used in R will be reshape2 that will be used to help the long or wide data to be converted into simpler form. Besides, the ggplot2 install will be used to visualize the number of viewers of each movie in the form of bar graph. And from the bar graph, it can be visualized better the most and the least movie to be recommended according to the number of viewers. The bar graph also will be used to visualize the distribution of item-based collaborative filtering. Hi. First and foremost, the purpose of the study is to generate a movie recommendation system by conducting the analysis of a collaborative filtering mechanism. In the results and discussion, I will present in 4 parts, which are data pre-processing, exploring similarities, visualization of most viewed movies, and item-based collaborative filtering. In the pre-processing data, the dataset has been transformed into a matrix form that comprises movie genre in order to begin the analysis, and dataset composed of 18 different movie genre. The matrix generated results as you can see here. The search metric was the second metric type to be established, and it was designed to make it easier to find a movie's genre by its title or movie ID. According to the movie ID, we can determine the genre for each of the first 6 films. The number 1 denotes the movie's genre, whereas 0 denotes that the specified genre does not apply to the film. We were able to deduce from the matrix that some films, such as Jumanji, had many genres, which are adventure, children, and fantasy, according to the search matrix. The current matrix was turned into a scatter matrix form in order to develop the movie's recommendation system. A new re-rating matrix metric class has been created. There are 105,339 ratings in the class of re-rating matrix, with a 668 times by 10,325 rating matrix being built in the new matrix. Then, collaborative filtering involves making movie recommendation to viewers based on the preference of a large number of other users. Since the link of similarities is significant in suggesting movies, similarities between users and movies were identified. The similarities were evaluated using recommended lab and a variety of operators including cosine, Pearson, and Jacob. The recommended lab library has been used. The movies have been recommended based on the data of the user's viewed movie history. The rating matrix was used to generate the similarities matrix, which reveals the similarities between movies that were seen by various individuals. The similarities matrix of both user choice on movies and the similarities of 4 separate users' movies is shown in the figure. The similarities matrix is a quantifiable method that is applied. The yellow boxes in the matrix have a diagonal pattern because they indicate similarities amongst themselves, and so the similarities are great. According to the similarities matrix, each user and movie have few similarities. Next, based on the graph, the figure depicts the top 5 most popular films based on the user data. It shows that the movie Pulp Fiction had the most spectators when compared to other films in 1994. Jurassic Park in 1993 was the least viewed or placed 5th among the top 5 most popular movies ever imagined. Item-based collaborative filtering has been the goal of the collaborative filtering system's development. The cosine approach has been used to discover the precise number of things that have the most similarities. The commonalities of objects were discovered after the study was completed. Item-based collaborative filtering was created as a new variable of the top suggestion variable to determine the quantity of films that each user should see. Most items were included or distributed in item number 1. This indicates that the user has been suggested several movies, with the least being item number 10. This showed that just a few films had received 10 recommendations. Table 1 shows the movies that were expected to be suggested to users. However, the distribution of the item-based collaborative filter reveals that just a few movies were recommended the majority of the time. And Table 1 displays the overall finding. That's it from me. Thank you.
As the conclusion, recommendation system helps users to filter the movie based on their preference. From the results obtained, it is predicted that Get Shorty and Bad Boys 1995 will be recommended to the user as the users prefer to watch the movie that has similarities in genre. This result obtained also due to similarities that shared among other users. As the system was built on a collaborative approach, it will produce increasingly explicit results as opposed to system based on an item-based technique. These techniques are based on individual user ratings, which limits your option for further research. With a collaborative approach, it computes the relationship between different clients and based on their evaluations, recommendations movie to others with similar interests, allowing users to explore more. It is an internet application that allows users to rate movies, then recommend suitable films based on ratings of others. And lastly, as this study limitation is the old dataset, it is recommended for future study to utilize better and latest dataset to recommend people the latest movie. By that, research movie will be recommended to the users and fits people preference nowadays. That's it from us. Thank you.
Okay, thank you very much for the presentation. This is one of the interesting paper. Do you have a question, guys, audience and other presenters? Okay. I have a little question, a small question. You said like the movie data set is about more than 10,000 movie, right? What is the source that you cater the data set?
We get the data set from the Movie Lens website where it provide various type of movie.
Do you have plan to separate? It seems like this is all the movie from around the world, right? Do you have a, because I think this is very interesting. Maybe do you have plan to classify the movie into like a language, or maybe from the country, like an India movie, Korean series, Thai series, or Malaysia movie?
Yes, that will be our plan. But in the future, yes, we will like to try and improve more in this movie recommendation system.
Good. This is a good idea. Okay, thank you very much again for
Thank
the
you so much,
presentation.
Thank you.
Yes. Yes. Okay. We will move to the last paper of our session today. The paper, namely comparative analysis for predicting football match outcomes based on Poisson models. Please welcome presenter Nasim Lasali from Faculty of Computer Science and Information Technology, UTHM.
Good evening and hi everyone. I am Nazim Ghazali, one of the co-author for this paper. Will represent my team to present a comparative analysis for predicting football match outcomes based on Poisson models. Table of content. Firstly, I will present about the introduction, then related work, before proceed to the experiment that consists about the dataset description and a bit of a description for the type of Poisson model that will be used in the experiment, then evaluation metric, result, and finally the conclusion for the paper. Introduction. As all of you know that association football, or also known as soccer, is the world's most popular sport. And prediction in football has become one of prominent research problem because of the various factors that can affect the outcome of football match. Whether internal factor that consists such as skill, teamwork, the physiology or psychology of the player, or external factors such as off advantage, weather of the distance traveled by the football team. In general, this study has three main objectives, which are to model football match outcome prediction using Poisson model, to predict the football match outcome prediction using the Poisson model, and lastly, to evaluate the prediction result based on the evaluation metric consists of the accuracy, log likelihood, AIC, and R squared. Related work. There are several works that are used Poisson model for football prediction. This Poisson model for football prediction consists of two main objectives, which are first, whether it's to predict the number of goals scored by the both football team, or to predict the football match outcome, whether win, loss, or draw in terms of probability distribution. And this is the list of the researcher that starting from Mahe 1982, Dixon and Cole 1997, Roux and Ferguson, Carlis and Zafran, Koopman and Lee, Angelini and Angelis, and lastly the Sonkos et al. At the 2019. The first Poisson model can be found as early 1982, that also known as Mahe model. The Mahe model is an independent Poisson model that estimates strength in defense and attack for football team based on the distribution of goal score for both home and away team. This basic model may have many weaknesses. However, they are still have a room for improvement. Later, this Mahe model set off the foundation for the many other football match outcome prediction model based on the Poisson model. Experiment. In this part of the experiment consists of two, which are the data set and the Poisson based model. Firstly, we go to the data set, but before that, the tools that we use in the experiment is the RStudio, which are the integrated development environment for the R language. And the data set that we use in this study is extracted from www.footballdata.co.uk that consists of the English Premier League EPL season 2015-2016 until season 2021-2022. And this image is the excerpt of the data set that consists of date, home team, away team, football team home goal, football team away goal, and FTR is stand for the full-time result. H is meant by home win, A means the away team win, and D draw. And now we proceed to the type of Poisson-based model that they use in the experiment. There are four types of Poisson-based model that we use in the experiment. Firstly is default Poisson model, which the basic like a Mahe model that use the distribution of goal score from the home and away team to estimate the strength and the of the attack and defense for both football team. Then another is the Dixon-Cole model, the improvement model, and then the Roux and Ferguson model, and lastly the Poisson regression model. Evaluation methods. There are four types of evaluation methods that has been selected to be used in this experiment to measure the performance of all the proposed Poisson model. Firstly is the accuracy, secondly log likelihood, third archaic information criteria, or also known as AIC, and lastly R squared. Result. The prediction accuracy is shown by three types of Poisson model, namely the default model, Dixon and Cole model, and Roux and Ferguson model successfully gain similar in terms of prediction accuracy by 45.45% as compared to the regression type Poisson model that getting slightly higher than three model which successfully gain about 46.67%. As the for likelihood, This encode model get the highest value compared to the others Poisson-based model. Note that the higher the value of likelihood, the better the fit of the prediction model. Meanwhile, the Dixon and Cole model successfully get the lowest value of AIC compared to the other model. And this AIC, note that the lowest the value of AIC, the better the model. And for the log likelihood, all the model get the same value or slightly better, except the regression type Poisson, which are successfully gain 0.82. As conclusion, we can conclude that this ENCODE model is the best model among all the model. Conclusion. This study seeks to compare the performance of 4 variations of Poisson model, namely the default model, the 2 well-known Poisson model with adjustment in the football prediction literature, which are the Dixon and Cole model and Root and Sample model. And lastly, the Poisson regression model. As the result, prediction accuracy among 3 models are same, which is 45 or 45%. Meanwhile, the prediction accuracy of 4 Poisson regression model is 46.67%, which is slightly higher than other 3 Poisson-based models. The result concluded that the best prediction model in this study among all of the presented Poisson-based model for the football prediction is Dixon and Cole model, because the value of log likelihood is the highest, meanwhile the value of IC is the lowest, although the R-square value is similar to the others prediction Poisson-based model. And thank you for your attention.
Thank you very much for the presentation. This is a time for question and answer. Guys, audience and presenters, do you have a question? Okay. This is question is like I just want to know, can we apply this idea to the volleyball or basketball or other sports?
Yes, actually yes. Actually, this not my project. I just present on behalf. So maybe this actually use the goal distribution. So we can use the volleyball or other like netball goal distribution, and then we can make it like same like football. Maybe we can construct like away team strength that divide for defense and offensive, and same like the home team attack offensive strength and the defensive strength. So it can use the same methodology to predict the match.
Okay, good. It's good. It's good for fan club.
Yeah.
So, okay. Thank you very much again for the presentation. So, I think our session will finish in nearly 5 minutes. So, all of you guys, both presenters and audience, can you open the camera? We can take a picture together. How about Arthur?
I have no permission to open.
Okay,
Sorry.
okay. It's okay. So, okay, I will count 1, 2, 3 and cheers. 1, 2, 3. Okay, thank you very much, all of you guys. This is a very interesting paper. So, nice to meet you all, guys. Okay, thank you very much for today. So I will close this session. Thank you again, all of audience and presenters. Bye-bye.
Thank you very much.
Thank you very much.
Okay. It's okay. Now we just start the session. Welcome to this session. This session is the session number IT3 underscore OL. The session name is Machine Learning and Big Data. And to be my honest, I'm Sweet Pumritikun. Today I'm this session chair. Okay, let me start with the this session we have like 1, 2, 3, 4, 5 talks. I think we have the 5 presenters also, and there will be 5 talk, and every speaker will have 12 minutes per presentation, and we have like 3 minutes, and in each question and answer or Q&A with every paper, then let concern about the limitation of your presentation. Okay, so we can okay, the Q&A we can handle if the audience or someone don't want to express the question on the stage. You can send the question by the chat, and I will ask for you. Okay, so then let's start with the first presentation. The presentation is titled on the machine learning based malicious payload detection and classification framework from the new web attacks. The presenter is Mr. Chanin Lamisani. Okay, if wrong pronunciation, I apologize for this. The speaker from Computer Science Department, Assumption University, Thailand. So if the speaker ready, please.
Hello everyone, welcome to our presentation on the paper, a machine learning-based malicious payload detection and classification framework for new web attacks. This presentation is brought to you by Dr. Raj Sudha, Dr. Titipong, and me from Computer Science Department of Assumption University of Thailand. Presentation, we are going to talk about cyber attack and especially web attack classification. We talk about related works, we talk about challenges and contribution, and we also talk about a customized framework which we propose for our research, and also a new data set for web application attack payloads. And finally, we come up with our experiments and our results and share them with you. Cyber crimes are arguably the biggest threat to modern companies. And with this current pandemic situation around, these threats are also becoming bigger. A significant chunk of all cyber threats to these companies are web application attacks. And in this presentation and paper, we try to look into various
web application attack using OWASP 2021 as our reference. Our dataset does not represent the exact WASP 2021 because we had to bring some of the previous year's categories which their attacks are still relevant, and we also could come up with the equivalent HTTP packet. Before jumping into our paper, we'd like to talk about related works. There has been a lot of research on this subject, and previous researchers tackled this issue differently. Moradi suggested an unprovised method based on autoencoders. Kathim and Gata focused on a single type of attack using deep learning and a single type of payload like XSS. Leo and Q introduced local then detect, which used attention-based deep learning. Finally, AIDs proposed by Kim used LSTM as their core model. As like any other research, we had so many challenges, and we tried to come up with a contribution with this paper. So this paper will propose a new data set which comes up with updated variant of web application attack payload. It also proposes a customized framework to extract and detect these attacks. We also share some ideas on feature extraction and how we come up with our feature extraction, and we will finally talk about how we tune the parameters for these models and how we come up with better accuracy. We share our experiment and experiment result in the last section. Before presenting our new dataset, we'd like to talk about why we need a new dataset. A lot of previous researchers either used a private dataset or used CSISC 2010 HTTP dataset. However, the issue with this dataset is the dataset is outdated and does not contain new variant of attacks. Researchers from Google, like Norving, also mentioned in their paper called Unreasonable Effectiveness of Data on how much having a fresh data can change our result. And basically, the Google Translator also is an example of effectiveness of these data. To perform our experiment, we come up with a customized framework to handle our requirements. In order to understand our frameworks, we have this simple illustration here to help us understand how our purpose framework works. Basically, we need to start with setting up a HTTP honeypot to start gathering these packets. And then we respond the user who sent us a packet, usually with 200. So they can send, if there is any other packet, they can send to us. Next, we're going to extract these packets, extract the payload actually from the HTTP packet, which means like the areas like cookies and areas like the HTTP parameters, post body, and stuff like that. We can extract this payload from this. Then we apply our machine learning model on these payloads and gather the results. Then this result can be reviewed by a domain expert, a command line application, or a dashboard, however it is needed. We do not represent exactly the WASP 2021. And this is how our final data set look like in terms of the attack payloads. In order to perform our experiment, we use scikit-learn and Crash Python libraries to perform pre-processing and modeling. For payload detection part, we take a character level approach, and we used 1024 features as our base number of features. We merge and combine all well-known data sets we could find out from industry and previous researches. We clean up the data set, and we also add the confusing keywords to the final clean payload data set. This is how our dataset generation process looks like. We categorize different attacks by like XXC, XSS, injection, RC, as we mentioned, and we start to reading the previous researches and all other dataset we could find out, and we can end up to our new dataset with our new categories. In order to make sure we can cover the most confusing keywords in terms of the malicious and we don't misclassify them, we add a lot of these misclassifying payloads to our killing dataset, and we append this to our final killing dataset. After generating and cleaning up our new dataset, we come up with exploratory data analysis. In this picture, these photos come up from the source code released with this paper. This analysis is done on the balanced version of our dataset, but for our own experiment, we use the unbalanced version of this. There is one thing to note here, which is we have a little payload in terms of like XXC and deserialize and serialize when it comes to event balanced data, which means we do lack these payloads in terms of in compared to the other payloads. Also, this shows the length, payload length distribution, which we can see we barely have any payload with more than 2,500 characters. Using Python scikit-learn library, we start to try different machine learning algorithms and models on our dataset. Here you can see an example on how we pipe out our character level extraction using maximum of 1024 features. We start to tune for different parameters like n-gram range and the kernel used. For query about how these functions work, you can go to scikit-learn documentation. You can also see here, you do a grid search to find out the best parameters for this model. So this is basically hyperparameter tuning around model. In order to ensure our result, beside the accuracy score, which is the number of true label, we come up with different evaluation metrics, namely precision, recall, F1 score, and also we come up with the confusion matrix. And because the accuracy was too high in our cases, we also utilize cross-validation to ensure our results are same. Here we can see our experiment results. We come up with, we understand, we do have, if we have more sample, we basically have a lot better results. We perform traditional machine learning analysis. We use 3 different models, SGD, RF, and SVM. Each of these methods correspond to a scikit-learn function. Overall, we can see the accuracy of SVM is higher than everything else. But if you look at the XXC, in terms of all the metrics, because we had less payload, even inside our balanced version of dataset, we can see becoming a lot shorter in these payloads. As mentioned previously, we used different measurements to validate our result. You can see how we do cross validation here, again using scikit-learning. And also, as we mentioned, we do have the result for confusion matrix. The confusion matrix, each of these methods, again, correspond to a scikit-learn function. So our focus should be on misdetected payloads. If we look into our confusion matrix for these different functions, we can see true labels against what we predicted. So for each of these results, we have to see how many of the exact label we also detect in the final label. So for example, in case of SVM, we can see we detect like more than 3,000 XSS payload, and we barely miss any of these payloads. In this presentation and paper, we come up with a customized framework to extract HTTP payload, and we also use different traditional machine learning model to analyze this data. We come up with the data extraction features. We come up with hyperparameter tuning to optimize these models. We also proposed a new dataset, which is updated and come up with a lot of new variants of this payload compared to the old dataset. But still, we had shortcoming in terms of some payload like XCC and decentralized. And this framework is not optimized for real-time production server, which can be considered as feature work by feature researchers. We hope you enjoyed this presentation and feel free to ask us any question you might have. Thank you so much for your attention.
Thank you for Mr. Shanin for presentation. Is there anyone for the question? Okay, so if there is no question, I have a few questions for this presentation. Okay, this paper is so interesting for using the model by machine learning base for the web app tags, right? And for you, but the other using the new data set and also use the cost variation for make the performance evaluation for the models. So that I will ask like this compare the three algorithm, right? And if you want to use one algorithm for this for one model for use like a realistic using or practical using, which one do you use? Do you choose that model for algorithm SGD, RF, or SVM? Why?
Yeah, hello. So basically for these models, actually, if we want to go to use this in like real servers, I would go with SVM because basically it takes less time to train when we have new data set and it's just like a lot faster. But if I really want to like take this to next level, I would probably change from traditional machine learning model to deep learning ones.
Okay, thank you for the answer. So if there is no question more, okay, so we'll go on with the next presentation. Okay, the next presentation is the entitled of the variational feature selection with the convolutional neural network for network intrusion classification. I think the presenter is Sithisak Saechung from Faculty of Informatics, Burapha University, Chonburi, Thailand. Okay, so let's present it.
Good afternoon, everyone. My name is Sithisak from Faculty of Informatics, Burapha University, Thailand. Today, I'm going to talking about variational feature selection with convolutional neural network for network intrusion classification. The presentation outline are included: introduction, problem formulation, proposed method, experiments and discussion, and the last one, conclusion. Let's start with introduction. As we know, the internet plays an important role in human lives. The internet is a worldwide network which used for communication between humans, including this conference session. But the internet is often attacked, which can highly damage to the business. Much research has been developed to improve the efficiency of intrusion classification to detect and classify to reduce the destructive resource. Rose et al. Introduced a feed-forward neural network. By the way, this method is efficient, but the effectiveness of intrusion classification is low because in case of imbalanced datasets. Al-Amadi et al. Presented a convolutional neural network and a recurrent neural network for classifying network intrusion. This method is more efficient, but it requires many epochs in the training step to achieve high accuracy. Khan et al. Proposed a CNN model using a softmax classifier. This model can improve the accuracy of intrusion classification, but unfortunately, this method uses many epochs for training a model to obtain high performance. Marcia et al. Introduced intrusion detection by applying a machine learning algorithm. However, the problem of the unbalanced CIC-IDA 2017 dataset affects the efficiency of networks. Kua et al. Proposed a CNN model combined with a feature selection by using a random forest with importance. This method is efficient. Nevertheless, it uses many epochs, about 2,500 epochs, for the training step of CNN, which consumes more time and resources. Much research has been attempted to improve efficiency of network intrusion classification. However, two problems are the unbalanced datasets and unsuitable feature selection, which those two problems are reduce the efficiency of network intrusion classification. CIC-IDA 2017 dataset by the Canadian Institute contains 78 features and 2.8 million samples, 9 classes of traffic, real-world datasets, most up-to-date network attack scenarios, but some features are unsuitable for network intrusion classification and highly unbalanced. As we seen in the table, the benign class have a huge percentage at 80%, but other classes such as DOS Golden Eye, DOS Slow HTTP test are less than 1%. It shows that some intrusion class has a highly unbalanced. Some network traffic features of this dataset are not suitable to represent network attacks. Feature selection is applied to choose important features in some research paper by Kerr et al. The main contribution of this paper is selection of features with low variance derived from standard deviation or SD value, called variational feature selection. Then the features are learned and classified by convolutional neural network or CNN to identify the intrusion classes. The proposed method is divided into 3 main steps. First, variational feature selection or VFS. Second, data resampling with smooth. Third, convolutional neural network or CNN learning. Variational feature selection or VFS is proposed to choose appropriate network traffic feature from the CIC-IDA 2017 dataset. In step 1, we compute standard deviation value for each network traffic features. Step 2, we source SD value of S in descending order. Step 3. Select the features when the SD less than threshold value to obtain network traffic features with low variance. This step will provide N features. The SD criteria are set to 56, 60, and 64 dimensions, and the threshold value as shown. SMOS is a technique for resampling data. It's used to solve the problem of unbalanced samples of minority classes in the CIC IDS 2017 dataset. Every training class are resampled into around 1.8 million samples for each class. For the CNN model, we use two sets of convolution, max pooling, and dropout as we seen in the picture. Then put the convolution output into neural network with 9 output nodes, represent as 9 class of network intrusion. The parameter we use ReLU as activation function, softmax as output function, spare categorical cross entropy as loss function, Adam optimizer, and batch size is 32. This experiment is done using Google Colab Pro with a GPU accelerator based on Python with TensorFlow, Keras, scikit-learn, and Implant library. The dataset is split into 80% training and 20% testing sets. The effectiveness of the proposed method and the state-of-the-art method is measured in terms of macro precision, macro recall, macro F1 score, and classification accuracy. The precision value of the proposed method at 200 epochs is 72.1%, which is higher than the state-of-the-art methods. The recall value of proposed method using 200 epochs is 83%, which is greater than the state-of-the-art methods. The F1 score of our proposed method is 76.1%, which is higher than the state-of-the-art methods. For the accuracy, the table shows that the highest classification accuracy is 98.8% from the SD2 CNN using 100 epochs. The classification accuracy of our method at 200 epochs is 98.5%, which is slightly lower than the SD2 CNN for 0.3%. For the conclusion, the proposed method consists of 3 main steps. First, network traffic features of the dataset are selected based on variational feature selection with low SD values. The reason for using low SD values is features with low variance intra-class are good feature. Second, the features are resampled by means of SMOS to balance samples in minority classes. Third, resampled features are trained and classified using a CNN to identify the network intrusion classes. In the experimental results, our proposed method achieved high precision, recall, F1 score, and classification accuracy. In future work, the proposed method will improve more precision. Thank you for your attention.
So Q&A session. Anyone for the question? No. For me, I think your
models is the good, that is the best performance of the existing method, because for the recall F1 score and also the classification accuracy, your proposed model methods had reached, or I think 90%, the highest of the classification accuracy, and also the best performance for F1 score and recall at the 200 epochs, right? And one question is, do you know why when you increase the epochs, for example, by your method by like 300 and 400, why that is the accuracy and the performance is going down? Do you know the reason?
In my opinion, I think that the model is too many train, because we are resampling the data set that increase the sample of data. But if we train it for many time, many epochs, I think it many cause it's I don't know surely 100%, but I think it can cause to the performance drop the performance.
Okay, so if for me, for my opinion, sometimes when the epochs will relate with your learning rate, because you not vary the learning rate, right? So sometimes
yes.
if the epochs too much, it will be not good. But if I recommend for you, sometimes if you extend this paper, you sometimes you can show the trending line of when you training curve, when you can see how the curve is stable, how the curve is not stable for the epochs. Okay.
Oh, thank you very much for the.
Okay, so to be on time, I will going to the next presenter. The next presenter, I think, is Mr. Nopadon Kong Samran, from Advanced Virtual and Intelligence Computing Center, Department of Mathematics and Computer Science, Faculty of Science, Chulalongkorn University. And he will present in the title of Thai Tokenizer Invariance Classification based on by LSTM and these two bird encoders. So let's go.
Greetings everyone. My name is Noparan Kongsamran. I am master student of Chulalongkorn University. My presentation topic is Thai Tokenizer Invariant Classification based on by LSTM and these two bird encoders. Let's begin with the introduction. Nowadays, many businesses capture customer desire and satisfaction on products and service from customer-provided sources, such as comments, reactions, and reviews. Natural language processing is applied to analyze this feedback to understand the customer. Most NLP learning models require word token ID as input. Different ID or different input means different meanings. In English, word boundaries are used to split the sentence into separate words. For example, this sentence can be split into I love NLP. However, Thai sentences are written without any spaces. There are no explicit word boundaries. One sentence can be separated into more than one different set of words. For example, this sentence can be broken into these two options. But more serious problems come when sentence is too hard. In this example, ฉันนั่งตากลมอยู่ริมตลิ่ง can be tokenized into two different meaning set of words. So, the objective of this research is to develop encoding method to solve Thai word boundaries in NLP approach. And by using the proposed method, different sets of words from the same sentence can be perceived in the same meaning by a machine. In this research, we sampled tokenization results from 74 tokenizers from Python NLP. Moreover, after our method is complete, we hope that this method can be able to be used later as pre-trained network. We select sentiment classification tasks as the testing method because it can be easily understood. Now then, I will talk about related works. There are 4 previous pieces of research that are related to this work. Begin with Siamese neural network. The objective of this paper is to recognize that 2 images are the same identity or not, which receive a free gift of similarity ranking and image identity classification. By using 2D convolutional encoder with twin weight sharing technique. The second paper is FastNet. In this paper, they propose triplet loss. The objective function of this loss is to minimize distance between the same identity and maximize between the rest by using 2D convolutional encoder on top with L2 normalization. Refer to the objective loss. The left picture here shows the minimum expected distance where bananas and buns are separable. And the right-hand side picture here shows a loss value increase when the negative vector is closer than the expected value. After that, the third paper, in defense of the triplet loss. In this paper, they propose a new triplet loss named triplet hard loss by select only 2 extreme values on each mini-batch, hard positive and hard negative. The difference between triplet loss and triplet hard loss is the loss computation. For example, if the batch size is 64, triplet loss calculate loss 64 times and average the result at backpropagation loss, but triplet hard loss by extreme value among 2 different samples between mini-batch. We select hard positive distance from the longest distance of same identities, and we select hard negative distance from the shortest distance of dissimilar identities. And the last paper is for classification tasks. Name is Random Feature for Large-Scale Kernel Machine. In this paper, they proposed random Fourier feature. This proposed method is a tool for approximate kernel truth. The kernel trick is a method that widely used by machine learning classification when data is not linearly separable. This section is about theoretical concept. In model architecture, I config distribute to the default version without any pre-trained weight and make BiRSTM output same as distribute. The encoding layer output dimension is set to 300 and each BiRSTM layer output dimension are set to 768. Both linear layer and L2 norm layer is set the output dimension to 768 also. In sentiment classifier, we transfer previous trained parameter into a new model and freeze parameter of encoder part. Random Fourier feature is used here to project data into higher dimension. Then classification layer is appended as the last layer. 2 datasets are created and used to test the performance of our proposed model. First is Google Map reviews, which I collect from 5 well-known fast food restaurants. And the second is Google Play application review, which I collect from 10 financial banking apps in Thailand. Each dataset is divided into 3 sets, 75 for training set, 10% for validation set, and 50% from testing set. After the dataset is created, this pipeline is applied. In the cleaning part, we remove non-Thai sentence and replace special character in the sentence as special token. In the tokenization part, we use 7 default tokenizer from PyThai NLP. And the duplicate result of this 7 tokenizer, we will remove it. And then, in the mini batching part, we use algorithmic shuffle to create a mini batch. The left picture here shows unshuffled dataset. And when we shuffle and slice a mini batch, a problem will occur. Truth that loss function cannot find hard positive value of the orange mini batch as shown in the right-hand side picture. In this slide, I will show you our shuffle design. First, number one. Number one here belongs to the triplet hash loss requirement. We need to group at least 2 samples from the same sentence. But if we group by 2, there is a chance that the group does not contain at least 2 same sentences as appeared in number 2. So here I group by T instead. Number 3 and number 4 are shuffling the group and unfolding the group into a normal dataset. And number 5, if we always do like this, 3 samples in a group will be the same for all time. So here I do a normal shuffle before the grouping process to increase combination variety. Back to the data pipeline. After mini batch is created, the training process is applied. We stop training when the loss is continuously increased for 5 times. This section is about experiment. Refer to the paper. This 4 tables from table 2 until table 5 show result similarity between 2 tokenizers. For example, this is table 2. The value inside pink circle represent the similarity portion when we compare classifiers that are trained from NER cut and UMM safe. The lower triangular matrix represents the comparison of similar results using proposed method, and the upper triangular represents results without our proposed method. Same as previous slide, this slide shows similarity ratio between 2 tokenizers, but we reduce the target class from 5 to 3. From the egg table before, the similarity improvement using the proposed encoders can be concluded as shown in this table. Percentage improvement is an average similarity among 7 different tokenizers. The highlighted cell indicate tokenizer that our proposed model that cannot beat the original model. In terms of accuracy, we can see that accuracy obtained from the restaurant review dataset using the proposed method model and boost the accuracy, although the overall classification results are not certified. Same as previous slide, this slide shows model accuracy but calculate from 3 card dataset. From the experiment, both proposed models perform well in both datasets, but all results from our proposed distributed model perform slightly lower accuracy than the original distributed model. In conclusion, this paper presents a method to solve Thai word bottleneck problem. The proposed method shows that after applying the trained neural network as a sentence encoder, every Thai sentence tokenizer gives similar results in terms of accuracy. Unlike a vanilla model, various sets of words are created from a same sentence with different tokenizers, resulting in uncontrollable performance. Thank you for your listening. If you have any question, you can ask me later at the conference meeting. Thank you.
Anyone for the question? Okay, so if there's no question for audience, so for me, I'm not familiar with it in like the NLP for the machine learning, but I just want to ask you some question. When you show the performance evaluation, yeah, that is good. You just summarize that. You can do it better from the 7 class to the 3 class and comparisons. But I think you use only the accuracies, right? For the comparison of the performance of the model, right? Use it only the accuracy parameter, right?
Yes, I use only the accuracy, but the main purpose of this paper is to control the output of each tokenizer classifier. Yeah.
Okay. So I don't know, but if why you didn't use like another parameter like recall or precision or the F1 score?
The main reason is that so I cannot fit it into the paper because the paper is require 6 page of them.
Okay.
And as the result is it fit the 6 page.
Okay. So I see. So you have it, but you didn't show the figures in this paper. So that because when we do the evaluation in the machine learning or any AI, right? But sometimes we know that the high accuracy sometimes it is not express the good performance. Sometimes like in classification in 3, right? But for example, like the accuracy will collect 100% only one class. But another class is have only few like test sets. Sometimes it's not good for use only the accuracy. Okay, that's fine. Because they didn't show in this figure. So thank you.
Okay, thank you also.
Okay, for the next presenters and the next title of the papers. The next paper is a new merging numerous small files approach for Hadoop distributed file system. Okay, next title will be changed to be the big data one. Okay, the presenter is the Mr. Adnan Ali from School of Electrical and Electronics Engineering from Nippon Table from Malaysia. I think from the USM, okay, from Malaysia. Okay, let's go.
Hello everyone. First of all, I would like to thank the organizers of this conference today. Let me start just by saying a few words about my own background. I'm a master student of science at USM Malaysia. The topic of my presentation is the new merging numerous small files approach for Hadoop distributed file system. By the end of this presentation, you will be familiar with the importance of resolving the small files issue that hinders the Hadoop performance. The content of presentation are as follows: abstract, introduction, objective, proposed method, results, conclusion, and references. Enormous data is being recorded every second from multiple streams and multiple environments. The traditional methods used in the past have failed in processing this huge amount of data that has led to specialized tools such as Hadoop, which are required to process this huge data by considering multiple factors. Hadoop framework has dominated on few files of large size but struggled massively in the matter of many small files. New algorithm for merging many small files into a single large file based on certain criteria such as type and size is proposed to overcome the small files issue. Our digitalized world has overwhelmed us with the enormous amount of data generated from multiple sources termed as big data. Big data lies under the following three different categories: structured, that follows a specific pattern which resides in a database; semi-structured, that follows a specific pattern but does not reside under a database table; and unstructured data that follows no specific pattern. Regardless, big data comes along with complications termed as 3 V's, namely volume, that refers to the size of the data; velocity, that refers to the speed at which data is generated; and variety, that refers to the difference between each batch of data generated. To process this big data, Apache Foundation, which is an open source, introduced Hadoop framework that is based on Google's architecture, Google File System, and MapReduce function. Since the traditional methods have failed to process these files, Hadoop framework can deliver distributed file system that enables scaling of computational storage and I/O bandwidth, which is capable of processing this huge big data. As we all know, Hadoop has been exceptional in processing big data files. Unfortunately, Hadoop has failed to deliver when it comes to many files of small size that degrades the performance of Hadoop but causes many other blockheads. The techniques deployed in the past used to merge files irrespective of file types and size that causes imbalance in the framework's processing criteria. One of the pioneer techniques of archiving the files is delivered by Apache, known as Hadoop Archive. Naming few of the other proposed techniques: Mapfile, appendable Hadoop archive, which uses efficient appending of new files to the prevailing merged data files using a first-fit algorithm, and the red-black tree technique for indexing. The spatiotemporal parameter uses spatiotemporal technique based on weights on the cluster. The objective is to deliver a pre-processing system that elevates Hadoop framework efficiency by developing a new algorithm for merging many small files into a large file based on certain criteria such as type and size. The developed algorithm will combine a large number of small files of the same type, which is text file of different formats. The system flow will be as follows. The system will scan all the files in the specified directory and define a maximum threshold. Unique files will be filtered and all files of specific type will be forwarded. A subset of files will be generated by removing the files that do not match the algorithm criteria. A recursive loop will deal with subset of files that simulate combined file size. Subset that exceed the maximum threshold will be ignored. The subset of files closest to the maximum threshold will be merged. In this section, we will discuss the result based on our evaluation. For evaluation, we deployed a virtual machine with the following configuration. Operating system was Ubuntu 20.04, 6 GB of RAM, storage size of 60 GB, and Hadoop framework version 2.10 was used. The test carried out contains 12 text files of different size ranging from 1 KB to 24 KB that contains a set of random words and numbers. The files less than 25% of the max threshold are considered small files. Maximum threshold was defined to be 50 KB, which means all the file merged will be closest to 50 KB. Simulation was executed 5 times to get an average result for each iteration. All the graphs are distributed into 2 categories, such as unmerged and merged. This pattern continues till the end of this section. For ease of referencing, I have converted the bytes per second to kilobytes per second. As seen in the graph, number of bytes are significantly reduced from 181 kilobytes to 90 bytes, and the number of bytes returned to the file was decreased from 3074 kilobytes to 1641 kilobytes per second. As seen in the graph, the launch data and data local map numbers were drastically reduced by 50% once these files were produced by the studied system, not the unmerged files. As seen in the graph, significant improvements are made in performance by 57% and a greater depth for time taken by another 50% where the files were produced by the study system. As seen in the graph, the files produced by the proposed method consumed very low number compared to those unprocessed files. As seen in the graph, files processed by the proposed method required extremely low megabytes. In this table, a generic comparison is being made between our proposed method and other methods proposed in the past. As seen, all the file merging techniques has benefited the Hadoop framework, but we considered all the disk I/O aspects to enhance the framework to higher extent. And as seen in the file size column, we considered small files to a very small file size, lowest of all, and we were able to generate higher results where the storage, read, and write were highly effective. Towards the conclusion, in the current era, one of the substantial issues lies in the file management system is huge data recorded from various sources. A new merging approach is presented, which is capable of increasing Hadoop's performance. Overall, Hadoop's performance has been increased by an approximate 50%. Unfortunately, the proposed method was limited to text file of multiple types, testing on limited data sets, implementation, or experimenting on a single node. In the future, it can be enhanced to provide extra compatibility with various file types and better utilization of HDFS resources, such as clusters. In this section, we have listed out all the references that we have used.
Okay.
By this, we conclude our presentation, and thank you for coming along.
Someone question for this paper? So there's no question from the audience. Okay, so my question is, I think you use the new merging numerous small files approach for the hardware of your that you express your hardware, right? And you compare with the existing method 3 of existing method. The results show that for I think the results show that's so very good. For I think your technique is yeah, I think that is merit. That is all merit of the file size, storage coherence, list coherence, and write coherence limit. Okay, so I would like to ask, like, is now have you tried to like use for practical data or practical using in the server or not, or you just on progress in the experiment?
As for the experiment, we just took like a random text generator or a tool, which is on website online, random text generator, and we put like words and letters, and we use those files to get our generation, because I believe as per the normal web blogs and these server files, they come in the same specific format. There's no specific format for those files. Okay, so we just mimic those files to do our experiment.
Okay, so can you give us the opinion, like if you apply this one for the practical using or the realistic using, that will be okay, or like you have to improve some things or not?
It should give you approximately 80 to 90% of the results we expect.
Okay. So
yeah, as if you, sorry to interrupt your talk, as if you review the log files of any web server, you will find the same things, as they have date, which is another numbers. You have text like this user visited this site, or this kind of element with special characters. So if you do a logical check, it does match up.
Yeah, okay. So yeah, that's a good experimentals, and I think yeah, that will be the good thing for the big data in future.
Sure.
Okay, thank you.
Thank you.
Okay, so yeah, the last paper of this session entitled of Data Balancing Modification for Multinomial Logistic Regression Models. Okay, the next speaker is Dr. รุ่งรัตติการนะครับเมืองไม้นะครับ if wrong pronunciation is I apologize for this speaker from Department of Mathematics and Statistics from นครสวรรค์ราชภัฏ University. Okay, so go ahead.
Good afternoon, everyone. I'm Lung Latikan Muang Mai from Nakhon Sawan Ratchapat University, Thailand. Today, I'm going to present a part of my work under the topic of data balancing modification for multinomial logistic regression model. As we know that data analysis and big data are widely used in various areas such as agriculture, education, medicine, including national development. The output of the analysis will be the basic of other works and also enable organization, especially forecasting the future. If we know that what's gonna happen in the future, we can handle with them. Also, we can make a plan, make a decision, and solve the problem. So many researchers and academic people continuously invented, developed, and improved these theories and methods for this analysis. However, there are many limitations and problems with the predictive model. One of the problems is imbalanced data that I'm working on. So the aim of my study is to evaluate how to modify the data balancings. And also, I would like to compare sampling techniques that we can apply in the process of data modification and end up with an application of a real data set. Now, let me give you a short brief of basic background of my work. Suppose that a sample or a data set is divided into many subgroups. I will focus on only two subgroups. The first one is the group with the most data. It is called the major group. Another one is the group with the least data. It is called the minor group. As we know that for the predictive value, if the amount of each subgroup is different, the finding might be biased into the majority of the data. That is the big problem that many people try to work on. There are four popular methods for collection. The first one is random oversampling or ROS. This method will add some data into the minor group, so the major and the minor groups are balanced. The second one is random undersampling or RUS. This method will removing some data from the major group, so both of them are balanced. The third method is hybrid. It is the combination between ROS, that is adding some data into the minor group, and RUS, that is removing some data from the major group, so both of them are balanced. And the last method is synthetic minority oversampling technique or SMOT. This method is different from the others because this method will synthesize brand new data. And in the data modification, we can apply some sampling technique. Here, I would like to introduce two techniques. The first one is simple random sampling or SRS. This technique is suitable for homogeneous population. However, for big data, the population might include various features. So the stratified sampling more suitable. These samples will be accurate, reliable, and good representative. The model we use here is multinomial logistic regression. in case that the response is categorical or qualitative dependent, so logistic regression was introduced. There are two types of logistic regression, depending on the number of levels of the response. If the response is dichotomous or divided only two levels, binary logistic regression will be applied. If it is divided more than two levels, multinomial logistic regression or MLR will be applied. To create the MLR model, there are 5 steps as follows. Step 1. Defining variable. Y will be set as the response. X will be set as the predictors. Step 2. Evaluating the collection of all variables. We can use chi-square test. Step 3. Create a proper model. First, interested group will be set as the baseline or the focus group. Then, Py equal K or the probability that the response is in the focus group will be calculated from equation 1, where Z is logit can be calculated from equation 2. As the response is categorical variable with G level, so the logit equation will be created for G minus 1 equation. Step 4. Checking the suitability of the proposed model. -2 log likelihood, Hosmer and Lemcho test, pseudo R-square will be considered, and end up with step 5, calculating an accuracy of the proposed model. Now, let's see my application. A real data set of factors affecting the choice of high school study of grade 9 students in Mueang District, Nakhon Sawan was set. First of all, we have to clean the data first, and then we create a proper model. Step 1, modifying the balance of the data. The response here is choosing to study at high school. It was divided into 3 groups: science, arts, and vocational education. As you can see that the most data is from science, so science was set as the major, and the least data is from arts. It is gonna be minor. Then P-collection methods and 2 sampling techniques were applied. So here we have 10 models in total as shown you in the table. Step 2, creating predictive models. Here, 23 predictors, including school size, student demography, and student opinion. Some of them are qualitative, so a dummy variable will be applied as well. After checking the collection, there were 20 predictors left for modeling. And next, creating the MLR model. Science was set as the baseline or the focus group, and then 2 logit equations were created. Py equal 1 or the probability that the response is in science. Py equal 2 or the probability of the response is in arts. Py equal 3 or the probability that the response is in vocational education, and Qy equal 0 or the probability that the response is not in the focus group. And then 2 logit equations will be calculated from equation 3 and equation 4. The parameter estimation of these 2 equations will be estimated using maximum likelihood estimator. Step 3, comparing all the models. As the response is divided into 3 groups, so 3 times T confusion metric will be created as shown you in table 2. After that, the accuracy rate will be calculated from equation 5. Also, the precision value of science, the precision value of arts, and the precision value of vocational education will be calculated as well. Now, let's see the results of my work. As shown you in table 3, the model fitting information of all models. Model 0 is the value of predictive model of imbalance data. Model 1 to Model 10 is the value of predictive model of balance data that adjust the balancing. We can see that the value of -2 log likelihood of fitted model were less than the value of new model. Also, the likelihood ratio test also confirmed that all of them are significant. This means the fitted models of all models were appropriate for prediction. In addition, the pseudo R-square of Koch and Snell and Nagel are considered. The highest value of pseudo R-square were from model 3 and followed by model 4. However, the value of pseudo R-square of the rest are not different and also not different from the pseudo R-square of imbalance data. So the accuracy value should be considered. As shown you in table 4, the predictive accuracy of all models are present here. The predictive accuracy of all models, you can see that the predictive accuracy of imbalance data model are the highest, is 70.9%. However, the predictive accuracy of balanced data model are not different. When we consider the value of predictive accuracy of the minor group or odd group, for imbalanced data model is less than 50%. After we adjust the balancing, we found that the predictive accuracy of the minor will increase and more than 50%. Also, in the same way of precision value, we can see that after we adjust the modification, after we adjust the data, the precision of odds will increase as well. So we can conclude that the model fitting information of both imbalance and balanced data were similar. However, the predictive accuracy of the minor were increased after data adjusting. And also, the collection of 3 methods, ROS, RUS, and hybrid, were similar and similar to imbalanced data. And also, the result is the same way as other research. Further work, I would like to apply SMART in the data modification. And after that, I would like to investigate other classification model. Thank you for attention.
Thank you. Is anyone for the question? So I think no. Okay. For this paper, and I think this presentation is very good. I think the presentation is so very clear. Okay, and I think for me there is no question for this one, but okay, I think I will ask like for the future works or like for this advantage for application in other works. Okay, so from these results, how do you think if for me if I use the logistic negation for classification, for some classification, and for example, I have 4 classes, and I have also imbalance data. But normally in nowadays, we try to use like augmented for data augmentation for increase the data in the minor group that you meaning. So the class that we have so few data, we use the augmentation to balance it. How do you think this one is work or not? For compare with your hypothesis of this paper.
Okay, thank you. Actually, this work is my extension. Before this, I divided the response only to group, that is interested group, and the rest of them gonna be a non-interested group. So that is quite a lot of paper they work on the logistic. But in fact, the response might be well include a lot of features that I'm trying to working on. To be honest, I'm a statistician, and I know the theory about the sampling. There are a lot of many methods to correct the data, to add some data or reduce some data, and I'm trying to find the best method to work with this. So this is just a part of my work that I played on, and also because of my response is a qualitative, so it's not easy to work with the smart, because smart we will get a brand new data. But for these three, just pick some of them. So I'm quite not sure that it's the best way or not. So actually, I'm still working on another one, and I try to make the balance both all of the group, not just only major and minor. But most the paper at the moment just try to make balance between major and minor group, and then they left the other. So I want to improve all of them to be balanced.
Thank you. I think because I think from the AI fields now, the data is the most important. We have to like using the pre-processing or data processing for make it the best before using the model. Okay, thank you so much. If I think this is the end of the session, I think co-host would not inform any information, right? Okay. Can we let me take a photo like the caption? I don't know. Anyone can open the camera for taking the photo together or not? เปิดกล้องถ่ายรูปกันหน่อยครับโอเคครับเดี๋ยวสักครู่นะครับโอเคนะครับน่าจะประมาณนี้นะครับโอเค we just taking the photo 1 2 3 okay thank you so much we will end this session thank you everyone thank you chair thank you co-host thank you speaker
Thank you อาจารย์สุวิทย์ครับ
ครับสวัสดีครับ
Thank you อาจารย์สวิทย์ครับเช่นกันครับ
Thank you สวัสดีค่ะ
สวัสดีครับ
ขอบคุณสำหรับคำแนะนำมากๆครับอาจารย์ครับ
ครับผม